Hello, welcome to GTA Official. This is a page where standard past questions and complex theories are going to be breaking down for you to aid understanding. So today we are going to solve past question on business statistics, which I have here. So I'm going to present it for you to go through to, and then I'll be reading the rules attached to it. So the section A, it is compulsory for you to answer the question 1. And then the section B2, we have 4 questions here, and we have 2 optional. So you have to answer 2 out of the section B, making it 3 in total at the end. So I'll be starting with the compulsory part, which is the section A. So we have a table here which says price X and then quantity sold is Y. I have drawn it here nicely for you to also see it here. So here I didn't bring the price. I represented it by X as they indicated here, and the Y2 as the quantity sold as they've also indicated it here. So the section A, the question 1A says that calculate the Pearson's coefficient of correlation and comment on your result, which is 10 marks. Okay, so the section A, question 1. The A says that we should calculate Pearson coefficient correlation. And then this session, mind you, we have 2 parts in this session. It is Pearson's coefficients and then the regression. So here we are going to solve both regression question and then Pearson coefficient correlation. So let's start with the Pearson coefficient correlation, which is the A. So our Pearson coefficient correlation, the formula is R equals N by sigma xy minus sigma x this multiplied by sigma y, all divided by your square root. Then you bring this here. N multiplied by sigma x squared minus sigma x all squared. Then you close your bracket. We open another bracket here, which is n by sigma y squared minus sigma y all squared. Then you close your bracket. So this is the formula for Pearson coefficient correlation, and we are going to use this to state the variables and then solve it. So now we have xy here, we have x squared, and then we have y squared, and another one too is s all squared and then y all squared. So now we have to get our sy. So let's create another session here, which will be our xy. Okay, our sy. So let's do the calculation. X multiplied by y. So 18 by 8, we'll get 144. 20 by 6, we'll get 120. 25 by 5, we'll get 125. 27 by 2, we'll get 54. Then 28 by 2, we'll get 56. 32 by 1, we will get 32. So we are done creating for our x, y. Now, here we can see we have x. Our x is here, our y is here, then our sy2 is here. Now, so let's look at the s squared. So s squared, we are going to square the whole of this x, okay? So 18 squared will give us s squared. So 18 squared will give us 324. 324. Our 20 squared will give us 400. 25 squared. 25 squared will give us 625. 27 squared will give us 729. 28 squared will give us 784. Then 32 squared, which is the last one. 32 squared will give us 1124. 1124. Like this. So now we are done looking for our s squared. Let's look at our y squared. Yeah, y squared. So let's square these two. Y squared. A squared will give us 64. C squared will give us 36. 5 squared will give us 25. 2 squared will give us 4. Another 2 squared will give us 4. Then 1 squared will give us 1. We are done with our x, y, sy, s squared, and then y squared. Now, let's state them here. So, our n will be, so we have n here, n here, n here, n here. And then someone will ask, what is the n doing here? So the n is the number of terms over here. So if we count the terms, we have 1, 2, 3, 4, 5, 6. So the n is 6. So let's state it. N equals 6. Then we have sigma x, y. So sigma sy, it means we are going to sum all this, all sy over here. So let's calculate it. We have 144 plus 120 plus 125 plus 54 plus 56 plus 32. And at the end, sigma xy will give us 531. Okay, hope you understand at this point. Now let's continue by looking for sigma s squared. So sigma s squared, sigma s squared too. Let's sum the whole of sigma s squared and see what we will get. We have 324 plus 400 plus 625 plus 729 plus 784 plus 1024. So when we sum the whole of this, our s squared will give us 3,886. Okay, yeah. So now let's look at our sigma y squared too. We'll be using this both in Pearson correlation coefficient and then the regression. So I want to state this and then leave it here so that we can use it both of them. So the sigma y squared, we have 64 plus 36 plus 25 plus 4 plus another 4 plus 1, which will give us 134 as our sigma y squared. Okay, now let's look at our sigma s, because we have sigma s here and then sigma y. We have our sigma y here. So let's look at our sigma x. Sigma s, we have 18 plus 20 plus 25 plus 27 plus 28, and then our last one, 32. Good. So we will get 150 as our sigma S. Then our sigma Y, we have 8 plus 6 plus 5 plus 2 plus another 2, then plus 1. Okay, then sigma Y will get 24. Hope you understand. Yeah, so we have this here. Now let's substitute them into the formula and see the end result that we will get for the Pearson coefficient correlation. So our R is equal to, our N is, let me draw this. Our N is 6 multiplied by sigma Sy. And then our sigma Sy is 531. Okay. Minus our sigma S. And we can see our sigma S here, 150. Multiplied by our sigma Y. Our sigma Y2 is 24. Okay, now let's come to the denominator. So the denominator too, we have our square root nicely here. Then you open your first bracket. Our n is 6 multiplied by sigma s squared. Our sigma s squared is 386. Okay, minus sigma s all squared. So we find out that our sigma s is 150. So 150 all squared. You close the bracket. Then you open another one. Okay. So our n is 6. Then multiplied by sigma y squared. Our y squared is 134. Okay. Multiplied by sigma y all squared. Sigma y is 24. So 24 all squared. Okay. Then you close the bracket. Now let's point this into our calculator and see what we will get. So if we point this in our calculator, we will get R equals minus 40, minus 440 for the numerator. Okay, let's look at the denominator too. So the denominator, we will get square root of, our square root is already there. So square root of 816 multiplied by 228. Okay, now let's point the whole of this into the calculator again and see what we will get. So our final answer is R equals negative 0.9598. Okay, and the question says that we should comment on our result. And here we can see that the R, which is the Pearson coefficient correlation, we had negative 0.9598. It is closer to negative 1. So here we are going to get strong negative correlation. Okay, so your comment will be that therefore, or just make it, therefore R equals 0 and negative 0.9598. So comment. Let me write it here. Comment. Our comment is strong negative correlation. Okay, so you are done with the question 1A. Let's move on to the B. The B says that we should determine the coefficient of determination. So B, coefficient of determination. So the coefficient of determination, it is always R, capital R squared is equal to our small r squared, which is negative 0.9598. Okay, so here we know that our small r is equal to negative 0.9598. So since this is equal to this, our r squared is equal to negative 0.9598 all squared. Okay, and let's point this on the calculator. 9598 all squared, and we will get r squared to be 0.9212. Okay, yeah, and you can bring it to a 3 decimal point, which will be r squared equals 0.921. Okay, yeah, so the next question is C. Find the ordinary least square regression equation. So here we are done with the correlation part. We are moving on to the regression part. Okay, so the C, I'll clean this side. So we are asked to find the ordinary least square regression equation. So our regression equation is always given us by y equals alpha hat plus beta hat sigma s. Okay, sigma s, like this. Now we have our sigma s here. We need to look for our alpha hat and then the beta hat. So let me start with the beta hat. Our beta hat is equal to n multiplied by sigma sy minus sigma s multiplied by sigma y. Okay, all divided by sigma s n by sigma s squared, sigma s squared, sorry, minus sigma s all squared. So this is the formula for beta hat. Okay, so now let's insert the figures in it and look at how we will get it. So beta hat is equal to, our n is 6, as we know. Our sigma sy, sigma sy is 531, like this. Then minus sigma x, our sigma s is 150, multiplied by sigma y, which is 24. Okay, so all divided by n is 6, multiplied by sigma s squared. Our sigma s squared is 3,886. Okay, minus our sigma s all squared. Sigma s is 150. Okay, all squared. Now let's point this on our calculator. We will get, let's do the numerator first. So we get 6 multiplied by 531 minus 150 squared multiplied by, no, not squared, sorry, 150 multiplied by 24. And we will get beta hat equals minus 414, all divided by 6 multiplied by 886 minus 150 all squared. We will get 816 like this. Now let's point it on the calculator and see the final answer for beta hat. So minus 414 all divided by 816. Our final answer is beta hat negative 0.507. Okay, negative 0.5. Okay, let me make it 5 decimal point or 4 decimal point, which will give us 35. So here for beta hat, we can make it 3 decimal point minus 0.507. Okay, yeah, so sorry, I think I made mistake here. It is beta x, not beta sigma s. Okay, now let's look at our alpha hat 2. So alpha hat is equal to sigma y minus beta hat multiplied by sigma x, all divided by n. Okay, so we have our sigma y here to be 24. So 24 minus our beta hat is 0.50735. So multiply by minus 0.50735. Okay, then our sigma s is 150 multiplied by 150. So now all divided by n. Our n is 6. Okay, now let's point this on the calculator. And we will get our alpha hat is equal to 16.683. Okay, 16.6. So let me make it 4 decimal place. Or let me also make it 5 as I did the other one. So therefore, this one should be therefore. So therefore, alpha hat is equal to 16.684. Like this. Now, we were given to find for the equation. So now let's insert this and this into the equation. So our y is equal to alpha hat is 16.684 plus our beta hat, but then we have negative here. So minus 0.507. Okay, x. So we will state that therefore, the least square regression equation is y equals 16.684 minus 0.507x. Okay, yeah, so we are done looking for it. Then the D says that predict the number of jackets to be sold if price is 40 Ghana cedis. Okay, so now we have the equation. They are asking us to predict a price to be sold So we got to know that Y was the quantity sold and then the S is price. So the price is 40 cedis here. Okay. So now D S equals 40. So let's insert it into this and see what we will get. So Y equals 16.684 minus 0.507 multiplied by 40. Okay, so let's point this 16.684 minus 0.507 multiplied by 40 cedis. And we will get Y equals negative 3.596. Okay, now we will conclude that since Y equals negative 3.596, there will not be any sales. Yeah, there will not be any sales. Okay, because of the negative. Because of the negative. Okay, so they wanted us to predict the number of jackets that can be sold, but then at the end we found out that the prediction we had negative, so there will not be any sales. Okay, yeah. So now let's look at the next question, which is question 2. Now we are moving on to the section B. So the section B, we will be taking the question 2. Here we are supposed to answer 2 questions, as I said earlier. So section BA. But before that, if you are new to this page, I'll urge you to like, comment, and subscribe so that anytime I upload videos like this, you can access them and prepare towards your exams. So the section B, question 2A, state 4 properties of the normal distribution. So before I help you or I start with this, this is the 4 properties, I would like to draw the curve. Okay, so this is how the curve looks like. So I'll be using this curve to give the 4 properties. One thing you have to take note is that in these 4 properties, the bell curve like this, it is all under this and everything is equal to 1. So first step is that it is in bell shape. If you look at it, it represents a bell. So your first property is that it is in bell shape. Bell shape curve. Okay. Then the second property is that the curve under the bell curve under this is equal to 1. Okay, so this is equal to 1. So it is the curve, sorry, the bell curve. The bell curve is equal to 1. Okay, which is 100%. 100%. Now the third one is that all this we use it to determine our mean, mode, and then the median. So here the mean, the median, and then the mode are all the same. Okay, yeah. So the mean, median, and mode are equal. Okay, so here since it is equal to 1, which means if we divide it, we get 0.5 here at the negative side and 0.5 at the positive side. Okay, so taking this, it means if we divide 2, we will get, what we will get is both sides will be the same. Okay, so it is going to be symmetric. So the next property, which is the final one, will be it is symmetric. Symmetrical. Yeah, let me make it that way. So these are the 4 properties of the normal distribution. Okay, now let's move on to the B. The B says that the weekly wages of the employees of Ghana Cocoa Board are normally distributed about the mean of 145. So B, our mean is 145 cedis with a standard deviation of 10 cedis. So standard deviation of standard deviation of 10 cedis. Okay, now find the probability of an employee having a weekly wage. So a weekly wage between 150 and 160. So probability that 150 is less than S is less than 160. Okay, now with this, we need to look for the formula to solve for this. And the formula also gives us as this will be equal to S minus our mean, all divided by our standard deviation. Okay, yeah, so here you can also replace it by N. All right, so since we have our S, which is 150, our mean to be 145, and then the median to be 10. Let's look at the I. So I, Z of 150, you get 150 minus 145, all divided by 10, which is our standard deviation. Now let's point this on our calculator, and we will get Z of 150 to be 0.5. Okay, now let's look at Z of 160 is equal to 160 minus 145 divided by 10. Okay, so if we also point this on the calculator, 160 minus 145 divided by 10. Okay, so 160 divided by 145, we will get 1.5. So our Z of 160 will give us 1.5. Okay, Z of 160 will give us 1.5. So now we have the Z of 150 and then the Z of 160. So we are going to refer to our the Z score table. Okay, and I'll be using the full Z score table. So when you are using the full Z score table and you get a Z score which is to the left, if you get a positive to the left, you just refer it to the Z score table, and any answer that you get is your final answer. So this one that we had positive, if I refer to the Z score table, any figure or any answer that I'll get there is my final answer. And then if you also refer to the Z score table with a negative Z score, any answer that you get when the Z score is to the left is your final answer too. So both of them, any answer that you get is your final score. Now, this one is stated that between 150 and 160. So when you encounter something like this, whereby you have two Z scores, when you refer to the Z score table, you deduct the small Z score from the higher Z score. So here we will be deducting 150, which is 0.5 from 160, which is 1.5. The answer that we will get from the z-score table. Okay. Now we will also look at where when we get a positive z-score, when it is at the right. So when it is at the right, you deduct it from 1, because we said that in the curve like this, everything, curve like this, everything is equal to 1. Okay, so you deduct it from 1 when you get a z-score to the right. Okay, yeah. So some of the terms they mostly use when you are dealing with this is that less than, greater than, or more. So when you get less, it means to the left, greater than to the right. Okay, so now let's draw the table for this, or the bell-shaped curve. Oh, so we have our bell curve like this, and here it's stated 0.5. So 0.5 will be at the middle, 0.5. Then our 1.52 come here, 1.5. So here will be the space. So now let's refer to the full table. So the full table, I'll be presenting it so that you also check. So 0.5, we will get let me do it this 0.5 is equal to 0.6, so we have 0.6915. Okay, then 1.5, 1.52, we have 0.9332. Okay, yeah. So now we have to deduct this from this. So probability of this 160. So probability of s less than 160 minus probability of x less than 150. Okay, in this form. So now we will have 0.9332 minus 0.6915. Okay, so if we subtract this 0.6915 from 0.9332, we will get 0.2417. Okay, so this is what we'll get. So here you just make your conclusion that therefore probability of 0.5 less than z-score, where z is also less than 1.5, is equal to 0.2417. Okay, you are done. Now let's look at the II. So the II also says that we should look at the probability that less than 130. So II will be probability of x less than 130. Okay, so less than 130 will z equals 130 minus 145, all divided by 10. Okay, if you point it on the calculator, you get z to be minus 1.5. Okay, and if you draw this, it will look like this, minus 1.5, because it is negative. We have our 0.5 here. Okay, so minus 1.5 will be here, and it will be at this point. Okay, so let's refer to the z-score. If you refer this to the z-score, we will get, so probability of z less than negative 1.5 is equal to 0.0668. Okay, yeah, so this is a less than 130. Okay, now let's look at the next question. So continuing with the I. So probability that more than 160 cities. So P equals RS. It says more than. So here we get greater than. Okay, 162 Ghana cities. Like this. Now let's insert it into the formula. In the formula, we get Z equals 162 minus 145. Okay, divided by 10, which is the standard deviation. So if we calculate this, we will get Z to be Z of 162 to be 1.7. Okay, now let's refer to the z-score table. But before that, let me draw the bell shape for us to see how it will look like. So something like this. So here, because it's stated more than, and more than is greater than, so it means that S, so let's take our S to be here. S is greater than 162. So greater than, it will come to this side. Okay, so 162. And when we solve, they had 1.7. So 1.7 to be this side. So it will take place here. Okay. Now, let's refer to the z-score table. So when we refer to the z-score table, we will get z of 162 is equal to 1.7, which will give us 0.9554. Okay, so as I explained earlier, if you get this, because it is to the right and the whole of this is equal to 1, you deduct this from 1 to get the number of the sample that was occupying here. Okay, so it will be 1 minus this 0.9554. Sorry. Okay, so we'll get 0.0446 as our 1.5, z of 6. So you conclude by saying probability of z greater than 162 is equal to 0.0446. Okay, yeah, so we are done with the question 2. Now we were given that we should solve 2 questions out of this session B. So now let's also take the question 4, which talks about the standard deviation mean. So I'll clean all this. Now we have a table giving amount in cities. Okay, and then we have meal. So we have 10 to 12, 12 to 14, 14 to 16, 16 to 18, then 18 to 20. Now, our 10 to 12 is 5. 12 to 14 is 8. 14 to 16 is 7. 16 to 18 is also 4. Then our 18 to 20 is 6. Okay. So this will be our frequency. So this will be our frequency. Now, let's look at the questions under it. AI says estimate the standard deviation. Okay, so let's state our standard deviation formula. So our standard deviation will be square root of sigma f s minus me all squared divided by sigma f minus 1. Okay, so this is the formula for our standard deviation, meaning we have to look for sigma f, which will be this. Then we look for our s. After that, we solve for our mean. Okay, so let's calculate for our s first. So our s is also the same as midpoint, our class midpoint. So I'll state here midpoint, which will be my x. Okay, so to get your class midpoint, you add the lower class limit to the upper class limit. After that, then you divide it by 2. The answer is your x. 22 divided by 2, you get 11. Okay, then 12 plus 14, you get 26. 26 divided by 2, you get 30. Okay, now 14 plus 16, you get 30. 30 divided by 2, you get 15. So if we check here, the difference is 2. So you can add 2 to this, getting 17 as your next one. Then 2 plus this 2, you get 19. Okay, yeah. So we are done with the x. After getting the s, we need to look for our mean, which is the next step. So our mean is equal to sigma fs divided by sigma f. Okay, so our mean is in this form. Now let's look for sigma fs, but then let's calculate for our fs first. So fs will be mil multiplied by the midpoint, which is the s. So 5 by 11 will give us 55. Then 8 by 30 will get 104. 7 by 15 will also get 105. 4 by 17, then we get 68. 9 by 19 will also get 114. Okay, now let's look for our sigma fs. So here too, we will look for our sigma f here. So sigma fs, if we point it on the calculator, we will get sigma fs. Our sigma f, if we calculate this, we will get 30. And then fs, sigma fs2, if you point it on the calculator too, we will get 444. 446, sorry. Yeah, 446. Now, we can calculate for our mean. So, it will be 446 divided by 30. and our mean will give us 14.867. Okay, so this is our mean. So after getting our mean, which is 14.867, now we need to look for x minus mean all squared. Okay, so here I'm going to do it in this way and then square it straight. If you also want to make it simple, you can just solve s minus mean. After that, then you come and square the numbers that you get at one side too. But then because of the space, I will just deduct the mean from the x and then square it straight so that we can do it fast. So x minus mean all squared. We have 11 for the first s. So 11 minus 14.867 will give you all squared will give you x minus mean all squared. So 11 minus 14.867 squared will give you 14.953. Okay, so 13 minus 14.867. If you point it all squared, you get 3.485. Now 15 minus 14.867, we will get 0.018. Okay, now let's look at 17 minus 14.867 all squared. We will also get 4.550. Then the last one, 19 minus 14.867. If you point it all squared, you get 17.082. Okay, now this is it. So we need to multiply this by the f, okay, which is the frequency, because we have sigma fs. After that, we sum all. Okay, so our f multiplied by s minus mean all squared will give you 5 multiplied by 14.953. We will get 74 f s minus mean all squared. So 74.765. Then 8 multiplied by 3.485. You get 27.88. Yeah, 888. Then 7 multiplied by 0.018. You get 0.126. Okay, now 4 multiplied by 4.550. We will get 18.2. Okay, then the last one, 6 multiplied by 17.082. With that one too, we will get 102.492. Okay, yeah. So let's look at the sigma fs multiply sigma f multiplied by s minus mean all squared. So if we calculate this, and this plus this, we will get sigma f s minus mean all squared. We will get 223.471. Okay, yeah. So we already know our sigma f, which is 30. So let's substitute them into the standard deviation formula. So standard deviation equals square root of our sigma f is sigma f multiplied by s minus mean all squared is 223.471, all divided by our sigma f is 30 minus 1, okay? So we will get square root of 223.471 all divided by 29, okay? Then we'll get our standard deviation to be 2.775, okay? Yeah, so when you get to this point, therefore the standard deviation is 2.775. Okay, now let's look at the II. The II. It says that estimate the median value. Okay, so II, median. So before we start, we go in more to solve the median, we will have to state our median formula. And then the median formula is given by median equals LM plus open bracket sigma F divided by 2 minus FCM all divided by FM. You close the bracket, multiply by CM. Okay, now let's look at the meaning of the LM, FCM, FM, and then the CM. So our LM, okay, so after setting the formula, before that, let me calculate for this. So our the position, the median class, okay. So the F, sigma F minus 1 divided by 2. That will give us the median class. So here we have 30 minus 1 divided by 2. Oh, sorry, it will be positive. Okay, so this. So we'll get 31 divided by 2, giving us 15.5. Okay, so the median class will give us 15. So here we have to create a cumulative frequency because median, we are going to use the cumulative frequency. So cumulative frequency, I'll create it here. Cumulative frequency. Okay, now with the cumulative frequency, we need to sum this. Okay, 1, 1. So our first frequency was 5. 5 plus 8, we will get 13. Then 13 plus 7, or 5 plus 8 plus 7. Okay, we will get 20 here. Then 20 plus 4, we get 24. Oh, sorry, 24 plus 6, then we get 30. So always when you are doing the cumulative frequency, your last class cumulative frequency will be the same as your frequency, the sigma F. Okay, so now let's look at the median class. So the median class position is 15.5. If you come here, you come and check the cumulative frequency that is the same as the 15.5 or greater than the 15.5. Okay, so if we check here 5 and 13, none of them are the same as it, but 20, you can find 15.5 in it, and it is also greater than this, and this is the first cumulative frequency. So our median class will be here 14 to 16. Okay, so median class is 14 to 16. Okay, good. Now let's look at the meaning of this. So our LM is the lowest class or lowest median class. Okay, let me make it lowest class limit of the median class. Then we all know our sigma f. So sigma f divided by 2. Okay, that one we know it already. Then our FCM. So the FCM is the cumulative frequency. Cumulative frequency preceding the median class. Okay, preceding the median class. I hope you get it. Then we look at our FM. FM is the FM is the mid frequency. Yeah, frequency of the median class. Okay. Now our CM is the class weight. So CM. Class weight. So now I just wanted to explain. That's why I've written it in this form. I'll just explain it so that we state the figures and calculate it. So we say that our LM is the lower class midpoint of the median class, and this is the median class. So the lowest class limit is 14. So our LM equals 14. Okay. Now our sigma F divided by 2 will give us sigma F divided by 2, which will be 30 divided by 2, giving us 15. Okay. And then our FM is the cumulative, the frequency of the the median class. Okay, so FM. So here, if we check the median class, we have 7 as for FM. Then our FCM is the cumulative frequency preceding the median class. So where is the median class? 14 to 16. And this is the cumulative frequency for the median class. But then it said preceding the median class, which means before the median class. And that is going to give us 30. So FCM equals 30. Okay. Now our CM is our weight. And our weight, we can find it by adding this to this, then we divide it by 2. Okay, so 10 plus 12 divided by 2, 10 plus 12 will get 22 divided by 2 will give us 11. Okay, yeah, so now let's insert it into the formula. So median. So it's left with the CM. And then our CM is our class weight. So to find your class weight, you look at the lower class limit and the upper class limit. So here you deduct your lower class limit from your upper class limit. So 12 minus 10, we will get 2. Okay, yeah, so that is the interval between it. So now let's substitute this into the formula. So median equals LM is 14 plus open bracket sigma F divided by 2 is 15. Okay, minus FCM is 13. Okay, all divided by FM is 7. Close your bracket. Then the CM is 2. Okay, now you point it on the calculator and you get it as 14. Let's solve here. 14 plus this 14 plus 15 minus 13, you get 2 divided by 7. Okay, multiply by 2 here. So this 14 plus 4 on 7. Okay, 14 plus 4 on 7, giving you 14.571. Okay, that's our median. Okay, so here you just conclude that the median, therefore, the median is 14.571, and you are done. Now let's look at the third one, I. So I'll clean here because we will be using this one. I will not clean out. Okay, let me just clean here. And the I says that calculate the coefficient of skewness and comment on your result. So coefficient of skewness, the formula is 3 by mean minus our median. So median, all divided by our standard deviation. Okay, so our mean, we had mean to be 14.867 minus the median is 14.571, all divided by the standard deviation. So our standard deviation 2 was 2.775. 2.775. Now let's point this on the calculator and see what we will get. If we point this, we will get the skewness to be 0.32. Okay, so they said we should comment on it. So let me read what I have here. It says that a small positive value indicates the distribution is slightly positive skewed. A few employees or amount in the higher value classes are pulling the mean above the median. Okay, a few employees of amounts in the higher a few employees or amounts in the higher value a few employees or amount in the higher value classes are pulling the mean above the median, but the skew is mild. Okay, yeah, so we are done with the I. Now let's look at the B. So the B, I'm not going to write it down, but then I'm going to give you the tips for you to understand it in your own way and use your own language or your own English to explain it. So here, it says that differentiate between descriptive and inferential statistics. So descriptive statistics, here we use summarizing and organizing to calculate the data to get the real fact, the main calculation, so that we can use it to make our conclusion. So here, that is where you are going to calculate for the mean, the median, the mode. You use charts, tables, and then all these things to make the conclusion. But if we also talk about the inferential is about you using a sample data, a group of data, to draw a conclusion. So assuming I take a class of students, and then I realize the number of students there, maybe my first 10, number of students in a row are all fair. I can conclude by using this data that I got that almost the class or all the class students there are fair. You understand? So the inferential, we talk about probability, guessing and hypothesis to make a conclusion. So that is all about it. And this is the end of our lesson. So I'll urge you to like, comment, and subscribe for more videos. Thank you.